Hi, Ngogi Simon again. Today we're going to be building a rather interesting project, and this project is in two parts. Part one, part two. Part one will be creating a Kafka producer, and we'll be syncing the data using Spark, and we'll be syncing to Postgres. Yeah, all this will be doing open source. Will not be using Confluent, so meaning you can do this project even with no extra cost. It's just going to be using Docker. You don't even need to install Kafka. You don't need to install Spark in your system. Yeah, so that will be part one. And part two will be a rather interesting one. It will be an AI SQL agent that can be able to interact with this database. So you see, like how we have the same database in Azure Synapse Analytics, we have in Power BI, such that you don't really need to be technical, you just need to know English. We'll be building something similar using the Open API. So let's get right into part one. We are going to discuss first a bit of theory and then get to the project implementation. Yeah. And then we'll get into part two some later time. So let's get right into this.
Yeah, this is the architecture. This is the architecture of our project, and we have our data coming from a faker. So we'll produce that data in using Python code, and then we are going to stream that data to Kafka, and we are going to use Spark for streaming this data, and we are going to sync to Postgres. So this is a very direct project, and I would say very, very doable. Yeah. We're not using Flink. Flink is a bit complicated when you involve OOP, and this is a lightweight version of how to do it using Spark. And we are going to get right into some theory. We want to explain things first a bit on the theory of Kafka and Spark, just to touch on some few areas that you really can't go ahead without without paying attention to. And if you just dive into the project, you just get lost. So I'm building this project with a view of a beginner friendly. So let's get into some theory. And well, well, Kafka and Kafka uh, and Spark use something called horizontal scaling, and I've just tried to explain how this works. And the difference between horizontal and vertical is I'll just explain it in this way. So let's say you have like my machine. This is my laptop, and I want to process some data, and it has a storage space of 500, so 500 GB. Yeah. So if the data exceeds that, I need to add a hard disk. If the data is lower, then I will need to plug off the hard disk. Yeah. So that's how vertical scaling is. You scale with demand. So yeah. But now there is horizontal scaling that it just creates this in some sort of servers and clusters and nodes in such a way that if there is it replicates the service, and if you just read how it does, we go through expanding the system capacity by adding more machine servers, yeah, instead of making one machine more powerful, often called scaling out. And this is how it works. It adds more machines, so it adds more clusters within itself, and they become like one network. Yeah, it distributes the workloads between the different workers or the nodes, and it coordinates all this. So they operate in parallel. So since each machine works independently on its own part of the workload, tasks get done faster overall. So yeah, so we'll look at Apache Kafka. And Apache Kafka, maybe I've given you a brief description. It's an open source distributed event streaming platform used for building real time data pipelines and streaming applications. So if you want to stream data real time at source, maybe data is produced now, you want it at the sync now with maybe a latency of milliseconds or whatever you want. And Kafka does that. So it was created by LinkedIn in 2011, donated to Apache Software. So Apache meaning it's open source. You can be able to do this for free, run it in a system for free. Yeah, so it was designed for high throughput, low latency, fault tolerance, and scalability. So why Kafka exists? So before Kafka, company used message brokers like RabbitMQ and that, and they wanted something that could handle millions of events, store event for days, replay old events, scale horizontally without downtime. So scales horizontally with demand. Yeah. And Kafka, you can store the data for up to 7 days. Yeah. And there are some core concepts in Apache Kafka that you can't really do Kafka without understanding. And there are topics. So this is a logical category feed name where records are published. So think of a topic as a folder where messages are stored. So in this, we're going to have a topic where we are going to publish or we are going to stream our data to. Yeah. And we have producers and consumers, just as the name suggests. So applications write, that's producer, and those that subscribe to are called consumers. And in between, the data is serialized into bytes. So we have this consumer that is able to deserialize that. Yeah, so that's why we have the two, the producer and the consumer. Yeah, and we have brokers. So a broker, so Kafka servers that store data in serve clients. So you need multiple brokers to form a cluster, and each broker has. So this is just like a server and partitions. These are topics are split into partitions for parallelism and scalability. So we have each partition is ordered, immutable, identified by number. You start from zero. Within a partition, messages are strictly ordered, and each message has an offset, like a line number or a fog will reach to offset, and offset is unique sequential ID assigned to each message. Within a partition, consumers track their last processed offset so that they can resume, maybe in case of crash or replay data by resetting the offset. These are just some of the things that you'll be able to see when we access the Kafka UI. We are not using Confluent, but I got you sorted. So let's continue. And the other one should be replication. So how this replicates the data. So it provides, how does it provide fault tolerance, and its data is replicated across multiple servers. And you have Zookeeper or craft mode, and Zookeeper is for older versions, and we have Kraft for newer versions. So Kafka has now built its own quorum controller, no external Zookeeper needed. But for this project, you're going to use the Zookeeper. I've uh, interacted in a shallow depth with Kraft mode, and Zookeeper is where I've interacted with it more, and so it will be easier for me to do this video using the Zookeeper, but it's not been maintained. Soon you won't be able to use it. And I've created this analogy. So within the Kafka, so I've given you a library analogy, and we have topics as the bookshelf. So in a library, we have bookshelves. So each topic is a bookshelf. Producers is the authors. Consumer is the person who reads. Brokers are the librarians. We have the people who manage that. We have people who manage. So partitions is the book volumes. Offset the page numbers. Replication is the extra copies. Zookeeper or craft mode is the head librarian who manages like everything. And we'll go to Apache Spark. Yeah, so I'm just giving you maybe a brief overview or intro, and you can get to really understand it on your own. But yeah, I think whatever I'm doing, you really have to research and really try to understand more. But also, this is very adequate. So Apache Spark is distributed computing framework for processing large-scale data quickly. and in batch or streaming. So initially it was designed for batch streaming, but now it has you can do the real time stream. Yeah, and why use Spark for streaming instead of the direct sync? So you could be asking yourself this: really, we can stream the data from the from the point of source to the database. Why do we need Spark? Why do we need Apache Flink? Yeah, and you can, by the way, you can also do that using Kafka Connect. And Kafka Connect, you can subscribe to a service called Confluent that manages this Kafka. And really, you can do that when you don't need heavy transformations, any enrichment, or any aggregations. And it's simple. And when you use Confluent Kafka, meaning you'll have to pay. So prepare yourself with the resources if you have, because scaling it will require many resources. So when to use Spark, I've given some instances. Is when you use Spark when you need data transformation, aggregations, joins. Remember, this is just for one data. We will have in some cases where we have more than one data set. Yeah, learning in real time, multiple outputs, where you want to have Postgres to Elasticsearch to S3 buckets, and when you want to handle back pressure. Yeah, so this is basically theory part. Yeah, and I think we'll get into the implementation of this project. Yeah, so let's open command prompt, and in my documents folder, I've created a file called as Kafka Postgres, and you can just come and use this. You can just come and create using that, but I've already created it, and you can see if you move to Kafka Postgres, you can see it's empty. Well, apart from the environment, so you can create the environment like this: minus m vnv vnv postgres vnv postgres. Yeah, with that, so you can just run that and it will create the Postgres environment. So we'll just activate it. Postgres scripts, and then activate, and you should see a prefix of your Postgres name here, meaning your environment is activated, and you should open VS Code like that. Yeah, it is. Yeah, it is Postgres, and I'll try to make this as large as it can be for you. Have view, where is view? Okay, so appearance, and I will zoom in. Yeah, so I think that's, yeah, and we'll create our first file using Docker Compose. As I said, if you have Docker installed in a system, this will work out for you very well. And for this Docker, we won't really code line by line, and I will want to copy paste this. I've already done this project somewhere else, and but for the others, we'll code together. For this, I will just explain whatever you're doing. Yeah. So you can see we have services, and you can see you have the first is Zookeeper, we have the broker for Kafka, we have the Postgres image, we have the Spark master, we have this, of course, if you have the Spark master, we have the Spark worker, and we have the Kafka UI. I told you we are not using Confluent, and that's why I have a Kafka UI for you, so that you can really visualize what's happening really and how the data is being synced. And so I think let me explain what you're doing. Yeah. So Kafka, these we use the Confluent Zookeeper image from Docker Hub. Yeah, and of course the name is Zookeeper, and we have one the pods, and it maps to that port. So 2181 to for the Zookeeper client connections, and you can see all that. And you have network, Kafka network, so connects the container to the custom Kafka network. Yeah, and we can go to the broker, just basically the same thing. So uses the Confluent Kafka image, that version, and the name is the name broker. That's the name that you'll find, and it depends on the Zookeeper. So for the Kafka broker to be up, the Zookeeper has to be up. So yeah, it maps the port 1993 to container port 1993 for external client connections. Yeah, and the environment. So I'm assigning the ID to 1, and for this it's just basically saying connects Kafka to the Zookeeper in instance of the Zookeeper container. Yeah, so Kafka listeners, so defines to listeners, Kafka advertised listeners. Yeah, Kafka listening protocol maps. So that's maps listener names to the plain text. And for this, we have no encryption protocol. You can have two ways in which you can encrypt your data, and there's the SASL and the SSL. If I get the naming wrong, forgive me, but that's how we encrypt. There are two ways. Maybe there are more than that, but those two ways is why I've come to interact with them previously. Yeah, and we have the Kafka sets for replication factor. So the sets the replication factor of 1. Yeah, for Kafka's internal offset topic. So there's the single broker and there's no replication for this, just a simple. And the network is the Kafka network. Remember, even for the Zookeeper is the Kafka network. So we have the Postgres, and it's really direct. So the image is Postgres 15, the name is Postgres. So we also set the security. So we have the Postgres user is Postgres password Postgres, and the database is reviews. And we have the port 5432, and we have this volume. So this volume, the init.sql, it's basically like we are saying we are mounting a local init.sql file. So we will have an init.sql file so this is what will have the commands to create our table. Yeah. So based on the commands that we'll have in that init.sql is what will be executed. And you can see we have the Kafka network. So we'll create init.sql and we'll create the table in that. Well, it's just the commands. Yeah. And we have the Spark master. So uses the Pitnami that. So Spark master, that's the name. And ports 8080. We will map port 8080 for the Spark's web UI. Yeah. So we'll access it at localhost 8080, and 7077 maps the port 7077 for the Spark master node. Communication and the environment is so it configures the container as the Spark master mode. Yeah, and the volumes, it mounts a local streamjob.py file to app stream.py in the container for the Spark job execution. So the Spark job, we are telling it that it will mount the stream job.py. So I think we should have already created that. So I think we should create the init.sql. Yeah. And we should create the stream job. The stream job.py. Yeah. And yeah, continue to the Spark worker. So for this uses the same thing. This is the same image. So the Spark worker, and it depends on the Spark. It depends on the Spark master. So it ensures the Spark master starts before the worker. You can see the sequence. And environment configures the container as a Spark worker node. And Spark master URL. That, yeah. So we have the last one is you probably not find it many times, but the Kafka UI. So uses the latest Kafka UI image from the web configuration page. So don't know the latest, you can just use that. And latest is if you want to install maybe a module and you don't know the version, you can just install just latest. And the name is Kafka UI, and we are going to access the port to 99,000. And so it maps host port 9,000 to container port 8080 for the Kafka UI web interface. You'll be able to see how this interface looks like when we set it up. And we have the Kafka clusters name local. So it names the Kafka cluster local in the UI. So the cluster will be called local. The Kafka that Bootstrap specifies, this will specify for this to 93 specifies the Kafka's broker internal address for UI connectivity. And then 21 Zookeeper 2181 specifies the Zookeeper address for UI connectivity. So it will connect to these two, the Kafka UI, and it depends on the broker. So Kafka has to be up and running for this to be up and running. And we have network, and it's Kafka network. Yeah. So yeah, so and I've come here and written network. These networks define a custom networks for services, and it names the network Kafka network. And the driver bridge, what I mean is uses the bridge network driver, allowing this will allow containers to communicate via shared network while remaining isolated from the host. So yeah, so this sets up a whole architecture. Yeah, and we can start this by running this command prompt. Yeah, and you can say docker compose app minus d, and that's the empty compose file. Okay, so okay, so save all, and it should get up and running. Yeah, you should see it's creating now. This might take us a bit of time to create everything. And yeah, we should see started. It should start as Zookeeper Postgres master worker in the Kafka UI. Yeah, and you should open, after all is up and running, you should be able to open Docker. Yeah, either you're running, yeah, Docker should be installed in your system. So there's not that route to access it via web. So it should be installed in your system, and you should be able to see that your containers are up and healthy. And when it starts, we should be able to really see our Kafka UI. Yeah, you'll be able to see it, and you should also be able to see our Spark UI when it starts. Yeah. So let's get into this. So this takes some time, but should be good to go, and it started. The Kafka UI has started. So it has not even taken that much of time. And yeah, it has started. Not much time it has taken. So okay, so we've opened Docker desktop. Okay, Docker desktop. Should be able to see your images. You should be able to see your container. Okay, I don't know why it's taking that long. Yeah, so you can see our Docker, and you can see all our images are up and running. Yeah, so you can see it's running, and you can see yeah, it's started. Yeah. So you can, let's see if you'll be able to access the the localhost 8080. We should be able to access our Spark UI because it's up and running. And oops, okay, and localhost 9000, 9000, and also this. I think we should give it some time for it to start. Uh-huh. Yeah. Spark Worker does not have an UI. That's interesting. Okay, we'll give them some time to start as we're getting a project done. Yeah, so yeah, it's mapped to 8080. So I think we can just we'll wait. We'll see after some time if it has started. Yeah, producer.py, this is our producer, and we'll create Python function that generates values and streams into Postgres. So we're going to import some libraries, and we're going to import JSON. This data is produced that import random. So we're going to be having data that is generated randomly. Import time. So we want to see the time when this was created, and then from Faker import Faker. The first one always has a small f, and the second one capital. Yeah, so you make sure you get your things right from Confluent Kafka, from Confluent Kafka, then import producer, import producer. Yeah, and from datetime, so dealing with datetime, from datetime, datetime, import datetime, import datetime. Yeah, and so we are going to initialize faker. So fake, just say fake, because faker, and that open parentheses, and we should have our function, and so we'll create def create transaction, create transaction, create transaction, and we should start. So we're going to have an asterisk. So we should have this. So we should have our first column will be transaction ID, and this will be okay. This will be generated. So this will be generated by Faker. So it's fake dot UAD4, and yeah. So comma, next column will be product ID. So product ID, and this also will be created by Faker. I fake dot u d for and yeah. So the other column, let's go to the other column. Uh, we'll have the product name, and we have a random choice, and we are going to give it. It will randomize things from our list. So we are going to give it a list, and it should create. It should create this. It should create a row based on some of these values of the product name. And we're going to give it random.choice, so it will randomize. Yeah, so random.choice. I think we have imported random, and we're going to give it. The first one is from brands. So we have iPhone, we have Techno, we have we have Samsung, some Samsung. This can be anything either way. We have itel, just picking out most common phone brands, Xiaomi, and you have Pixel, the Google Pixel one, and Pixel, yeah, and maybe Nokia and Redmi, and comma, we have Nokia and Redmi, and this should be done. Yeah, so random choice. Yeah, and we should go to the next. And the fourth column is customer ID. So we have customer customer ID, and we have fake also this fake dot UID UID 4 and generate comma, and then we have the other one is city. Yeah, okay, so city, and also you should create another list. Yeah, so city, and we have random dot choice random dot choice, and we have a list. Yeah, so I come from Kenya, and those will be the cities that I will name. So probably you have heard of Nairobi and Mombasa. So wherever that you're watching this from, when you come to Kenya, these are cities that you might visit. We have Nakuru, we have Kisumu, and let me add Nyeri, Eldoret. Yeah, I think that's enough. And the other one is region. So this will be rather simple. Region, just, and then it'll be random dot choice. Okay, so random dot choice, and we have a list, and we have just the four regions that you probably have heard of. We have central, the five regions rather, and north. We have south, and we have east and west, and west. Yeah. So comma, and also here you should have a comma, and let's go to the other. It's transaction date. So when did this transaction occurs? This is something that if we are the reason why we have real-time processing. We cannot really have it without date. Yeah, so you should have date time dot the time and it's I'm trying to look time and should have this. So let me just copy paste this. Yeah, so comma and we should have product price and we should have product price product price and I will create this above. Let me just show you in a binit product quantity. You can see we are selecting variables that we don't really have and we'll create that. So we have product quantity, product quantity, and we have this as product quantity. Again, we also create variables for this. And the other one is total amount, total amount, and we should have total amount. We'll create these variables in a few. And customer value category. So we have customer value category and we have also that customer value category. We'll create this also. So I'll show you my thinking around this value category. And the last one, payment method. Okay, so payment method and we have random dot choice. This will be a list. So how did they pay? Random dot choice, just like that. They are one above, and we have some various ways you can pay. So in Kenya, we have something called M-Pesa. We have also Fuliza. We have something else that was introduced by someone called Hustler Fund. Yeah, and we have cash. We have credit cards. So just stop it there. Credit card. Yeah, and we should define this. And here we should come and define product price. Yeah, and we want to create a figure that's between 1 and 2000. So we should random dot uniform and we have the figure should be between 1 and 1000, and we want to round this also. Let's round this to two decimal places, so we should have round the beginning, yeah, and around at the beginning, and between here, between the last two, we should have 2. And then let's also define product quantity. Yeah, and this should be random dot rand int, so it should randomize anything. The quantity should be between 1 and 10. Don't want outrageous values. We want to make this as realistic as possible, and we have total amount, and we have round everything. So we have product price times product quantity. Yeah, so basically that's the math times product quantity. Yeah, and we want to define this range, and we want to give a range, just that if our total amount, if someone buys goods worth more than 10k, then they are high value. If between 10k and 5k, that's mid value, and anything below 5k is low value. So you should have an if total amount is greater than 10,000, then customer customer then customer value category, remember that we created. Then remember, so your customer value category equals high value. High value. Yeah. And then so we should have an elif. Total amount. Total amount is greater or equal is greater or equal to 5k. Then greater or equal to 5,000. Then this should be, so the elif is can't have, so indentation very key. Elif then customer value category is equals to middle level, mid value, and then you have an else. So else customer value category equals to low value. Yeah, so if you are using SQL, these will have been case statements. Yeah, so maybe a comment here, damn, where is that? Okay, so determine customer value category. Customer value category. Yeah, so and then you should have the function, the other main function, and we'll call it main. So def, this is what we run actually. So we should have this, and I don't know why it has an issue. Is it the indentation? Yeah, so it's good. So we should have producer equals pro produce so producer, and then you have bootstrap server, boot boot bootstrap dot bootstrap dot servers. Bootstrap dot servers, and we have localhost 1993, and we have we'll create a while statement. So while true, okay, so while true we should have transaction data, transaction data, and you should have create transaction so you have that function, and you should have producer dot produce dot produce, and I should create a topic here. Topic, we'll call it transaction. Okay, so topic, we'll call it transaction. Okay, so then you should have a key, and the key will be the transaction ID. So we'll come into the transaction data, transaction data, and we have transaction ID, and we have value equals to JSON dot dumps. Then you have transaction data, transaction data, yeah, and you have a callback. This will create this function, and it's called delivery report. And we'll have so it will have to rest some minutes, so it will sleep for 5 minutes until the next one is produced. 5 seconds rather. So Paul, okay, so time.sleep, okay, time.sleep, 5 seconds, and we have, so okay, so yeah, so we'll call this name main, and in. So let's create this delivery report, and should be here. Def function, so the name is delivery report, and some constraints that will be here, and we have that. And I have if error, then print delivery failed. If there's an error, so you have error in message. So if there's an error, it will print delivery failed. And if it printed well, it will write delivered to the topic name. And in this case is transaction, so it will write here on the terminal delivered to that to that topic. Yeah, so if error, so what error, so we have print. So print. Okay, so what did you do here? Okay, yeah. So if error, we have print. Yeah, to make our code neater. Print. We have F, and I should have delivery failed. You should have the message here. Failed. And we have yeah, so else you should print to. So we have delivered to. You should have the message to topic. You should have the message, and then you should have the topic. Yeah, and this should give us our. This should ideally, when we run this, it should give us. It should be able to run. And let's see if it opened. Yeah, and you can see the Spark opened, and Kafka it should also open. You can see it's running, and yeah, it's opening. So you can see the Spark, and you can see the worker, a completed application. So you can see a live worker. This is alive. The worker is alive. You can see cores are at 4, memory in use. There is 0 job running. 0 has been completed. You have not submitted any job here. Kafka is still opening, and you can see our Docker is still up and running. So 29 minutes ago, that's when we got this, and you can see our Kafka is down. Our broker is down. And it's up now. Don't know why. Yeah. So you should, this is your local UI. So you can see we have nothing. And the broker here, okay. Okay, so topics. You can see our job has not been started. It's running quite slow. Let us install this. You can see the Faker and Confluent Kafka. Let's install this so that our job will not have any issue. Let's see. Okay, still quite slow. Topics, ideally it should have none either way. But yeah. Okay, so I think we'll have to see. It's when it starts to produce data to this, and this should be installing, and we should see if our our data is being produced by this function. Yeah, so we should have the init.sql query, and we should create this table. So we should create this table, by the way. So all this we should create, and this is the query. Just simple. So just going to create the table, and just normal SQL code how you'd have created. This is the code. So creatable if not exists. So product transactions, and so we can see transaction ID, product name. All these columns are in in our producer, and they should be also in our consumer. We'll see that in a few. Okay, so the broker you can see, our broker is up to 1993. Topic, no topic found. Yeah, and this should be installed in a hurry so that you can get to produce. So you should say Python and produce dot py. That's how you run Python files. And let's see. So if it runs, you should have message. It should have this. It should have this delivery delivered to transactions now. Delivered to transaction, and you can see it's producing data. And there's only one way to find out. Checking at transaction, and you can see the number of messages, and you can see the data that is creating. So you can come and see it's it's creating, and you can be able to see messages here. The message that's creating, maybe you can see here, you can see the transaction ID, the product ID, the product name, customer ID, city, region, transaction date, yeah, product price, product quantity, yeah, it has considered this as low value, and it has paid through Hustler Fund. Now we need to get this data to Postgres. Yeah, so like the first part is like done. So how do we get this data to Postgres? Yeah, so we'll have to create a stream job. Yeah, and this does this using Spark and PySpark. And if you have used PySpark before, this might be easier. Yeah, so let's start. So do we leave the job running? No, let's not. Just stop it and create first our code. Yeah, so we should come here and say import. Yes, and from and then from PySpark import Spark session, and then you're going to import all functions and all like the data types, and then you're going to import login. So basically, these are some of the things you can just don't really even need to code line by line. Uh, yeah. So and then you're going to configure login. So you should have login dot basic config, yeah, and we have whenever we want to see the log, we want to really see if it fails. We want to see why is it failing, rather than try to spend the day debugging, spend the whole day debugging. A job that the logs can be here, and you can do it rather simple if you really know what you are doing. Yeah, so you have login, yeah, dot get logger, and yeah, that function should be available here. Don't know why. Yeah, so get logger, and so Kafka Spark streaming, and this is the name that you're going to give our job. Really, yeah. So we have Kafka Spark streaming. Spark Spark streaming. Yeah. And I'll just comment this and say configure login. If you are following these, you'll be able to do it. And we're going to create a Spark session. So if you're using notebooks, probably if you have used Spark, we just create Spark session builder, app name, and then we build. And then so basically that's the normal version is when you are reading dataset. So it will Spark read the app name. So if you want to read the header as true or the header as part of the data, yeah, just so yeah, we are going to create this. So we're going to create Spark session. Spark session, and we have this. We are going to create and configure Spark session. Yeah. So maybe just comment create and configure Spark session. Just write whatever you're going to be doing. Yeah, and I want to return Spark session. Spark session dot builder, and the app name is Spark name, and we want to implement checkpoint location so that it can run from the previous last job. And we have partitions. We have shuffle. So we have how Spark will read. So if you look at how it does shuffling and how it processes data, we'll have partitions into two. And allow me to copy paste this because it's we have to install like jar files. Yeah, and this will be used to connect, and you get this from Maven packages. So the Spark files you have to like install them to your system like manually first. No. You get the code. So you go to the Maven repository and get all this, but it's available here. A lot of a lot of work to really get the specific connector that you want. And if you mess up with the connector, even if you've just installed, it really gives you headache. Yeah. So you're also going to create the schema for the transaction data. Yeah. So so we just like you see all these we're just adding here. Let me just add one and you can see whatever I'm doing. So you can see the schema, and you're going to also give it a data type here. Yeah. So this is the data type that will be detected in the in the in the data warehouse, or in this case in our database. I should have the first one. So we have the struct field, and we have so the first one is the transaction ID. Transaction ID, and we have string type. So this is string type, and really copying all these is really a lot of work, and it's repetitive stuff. Yeah. So let me just copy paste this. Just going to create for every column there. So and we should have the second step will be to process the streams. Yeah, so we are just going to set from where we are reading, so from the bootstrap server, from which topic, and how do you want to read it. We are going to setup, offset, and we can also copy this function that I wrote. Yeah, so we are telling it we are going to read format from Kafka, and we are setting this Kafka broker to 9093, and this is our broker. So you can be able to see here. You can be able to see here, and our broker is this. So you are reading from this. So broker to 1993, yeah, and you can see you're reading from the transaction topic and latest, yeah. So here we'll have a function to transform our date column here. So this is it. So okay, so there's an issue with indenting, and okay, yeah. So what you're doing here, we are changing the format of the transaction date to really make it date type, so that we'll load the data. And you can see here we have transaction date timestamp, so you want to make it in the right format. So we are changing this. That's the transformation. And the other function, I think I can write this. So this is to sync the data to Postgres. Yeah. So write to Postgres. And so we are going to have two parameters, and we are going to have the batch df and the batch id. So we'll put that batch df and batch id. Yeah, so we're going to write. So if I would write this is write the data frame to Postgres, data frame to Postgres DB. Yeah, so we are going to have a try except. Yeah, and okay, so what's happening here? So try. So batch df, and we have just the parameters really. So the connections like how we connect to the DB. Yeah. So we'll have the format is JBDC, JDBC connection. Yeah. The connection type, JDBC. And you should have option. We are going to connect to, I think, let me just copy all this. Yeah, so we have JBDC connection, and we are connecting to Postgres. So Postgres port 5432, and we are connecting to the reviews, and all this is here. So let's open this, and you can see here on Postgres we have our DBs called review. So you're connecting to that database, and you can see we have the table product transactions, and the product transactions is this. So connecting to that, and connecting the user is Postgres, password Postgres, and you're using driver as connection, and the mode is append, meaning all new data will be added. Yeah. So we can come here, the last one, and yeah, we're just telling it. So we just like try the Spark session, it should start, and we are just going to start the job. Yeah, so we are going to write the stream. So we are going to use this write to Postgres, this to connect first, and then the output mode to connect. And then we should, when it starts, it should write all this. So just login info. So login info that we set up here. So when it starts, it should stream in application started and application failed, Spark session stopped. Yeah. So really that should get you like done. And we're just going to install. Yeah, so the terminal we are going to install Postgres. We are going to install PySpark, sorry. And then we should submit our job. Yeah. So I think we should get now we should get our data like we should get our producer to start producing. If install, you can see the errors have gone. And we're almost through. And I should have Python producer.py, and it should start producing now. Yeah, let produce. If produce 1,000 files, we'll find them. And this is still installing. And then you should have the command. So in this command, it's just we are going to have some packages, and it's the Postgres driver. We're going to install it here, and we are going to submit just the stream job.py using this long command, and our job should be up and running. Should paste this one line, so you should see this Docker execution and Spark master Spark submit. Then we're going to install these two, this Spark to Kafka, and this Postgres for our job to work. And it should start downloading some stuff. So it should start downloading like these two, and then submit the job, and we should see things happening in our. So you can see a Spark, nothing is running, and you can see in our topic we should have data, so 38 now. So let's see if it's increasing. Just 38, 40. This zero running. Can see it's.
Yeah, so we have downloaded the job and it's downloading the Kafka, the Kafka Spark connector and the Postgres connector from the Spark, so that you can be able to sync the data. Yeah, and maybe we can have a look at our DB. Yeah, our Postgres DB that is. and see if we currently have data. Yeah. But that is depending on your network. This may take forever. This may take very few minutes. So let's connect to our Docker. This Postgres, as you can see, and we are connecting to the Postgres, and the database user is Postgres. Remember, and we are connecting to previous database. Yeah, we have connected to it, and let's see what we have in that DB. And we have one table, product transactions, and let's see if we have data really, or if I have. Uh, you can see there is no row, there is nothing, there's nothing, and this is still downloading Spark driver, registering. There are a lot of logs, really. Let's see if it will fail us or if it will work. And also, let me show you the Spark UI. Maybe can be able to see this Spark, and you can see it's still zero running, zero completed, and Kafka is still syncing our data. Yeah, 106. Let's see. Initialized block manager. Well, that's interesting. Successfully started service. Okay, we should wait for some minutes, and let's see if it will disappoint us. So you can see still zero running. If one starts, you'll be able to see here. Currently, it has not started, and yeah, it's Kafka commit serializer. Yeah, as we said, key value deserializer. As we said, Kafka serializes messages, and we'll need to deserialize this. And you can see it has recorded the timestamp, and you can see it has synced the data. So you can see offset 110. You can show you here transaction 116. And if we will come to our DB here, we are around that number. We should be around, so we are 122, damn it. Okay, so let's see if it has submitted, and we still have zero running. Okay, let's wait, see if it will register this. And as our job stopped, now it's still okay. Okay, committed offsets. Okay, this is interesting. Job should be detecting. Still have zero running, and this has 134 messages, and still zero running. Okay, let's come and try to read the logs. Okay, 129 on that transaction on that is interesting. Okay, killing all tasks. Okay, well. Let's see. Yeah, we still have 0. Let's try and see what's happening. Now if we come to Docker, we see, let's see, damn, we have our data is being synced. You can see that's rather very interesting. It's writing, but it's not detecting our job has started. It should show that our job has started. Don't know why. This is rather strange. I don't know what's up with my resources, but Kafka is syncing the data. You have Kafka is schedule the data, and we have our data being scheduled. If we can quit, and let's see now how many data we have. We have 39 rows. Let's quit. Let's see, we have 1 rows, and we can see transaction ID, product name, customer ID, city, region, transaction date, product price. Yeah, and yeah, you can see that. You can see our data is being synced to source. "46 rows. And this brings us to the end of part 1. Yeah, remember, as I said, we have part 1, part 2. This brings us to the end of part 1, and part 2 will create an agent that connects directly to this database. So this agent is just like the one in Azure's Synapse Analytics, the one like in Power BI. So we create something similar and try to understand our data that maybe we don't really need a data analyst who is that technical. Just need a data analyst to understand the data, who understands the dynamic and the market, and really who understands English. Yeah. So if you want to learn that, let's meet part 2. So you can see 55 rows. And this is all that will be for part 1 today. Yeah, see you in part 2. Bye.